Hello dear students, welcome to my channel. This is your favorite channel for studying class 11th and 12th JEE Neet. Today we are going to discuss about electric charges and field. थोड़ा सा फिजिक्स का तड़का डाल रहे हैं कॉन्सेप्ट क्लियर करने के लिए. फिजिक्स बहुत ही ज़्यादा कॉन्सेप्चुअल सब्जेक्ट है. If you know the concept and theories, you can do numericals easily. Practice them. So today we are going to discuss this chapter, electric charges and field. I'll try to make you understand every topic in 15 minutes so you can understand it better. We'll start with the basics like Coulomb's law, okay? Coulomb's law. So first you need to understand what is charges. Charges are basically two types, right? Positive charge and negative charge. Positive and negative. Suppose you have electron, so how much negative it is? It is minus 1.6 into 10 inverse 19. The unit of charge is coulomb. Unit of charge coulomb. So this chapter is basically a part of electrostatic. Electrostatic means study of charge. Study of charge at rest. How many properties it exhibit at rest? So study of charge at rest, we are going to discuss this. And unit of charge is coulomb, right? It is represented as capital C. So if we have proton or positive charge, it could be written as proton 1.6 into 10 inverse 19 coulomb, okay? So in an object, there is a multiple charges, it consists of so many positive charges or negative charges, right? If there is positive charge is more than negative charge, then that body is said to be positive charge body. If there is negative charges more than positive charge, then body is said to be negative charge. And if both are equal, it is known as neutral body, okay? So Coulomb study about the charges and give a law regarding that, which is known as Coulomb's law. It is kind of similar to the gravitational law, Newton's law of gravitation. You have heard about the Newton's law of gravitation, that is Fg G m1 m2 by r square, right? Here the m1 and m2 are the masses, r is the distance between their centers, and g is the gravitational constant. Just the value of g is 6.67 into 10 inverse 11. Unit you can write down Newton meter square per kg square. That was all about the masses. Now the Coulombs state the same law. Coulombs state the same law regarding the charges. Suppose you have charges q1 and q2. These are considered point charges. It means their diameter is so small. Consider as point charges. And their distance is r. R is the distance between them. Then Coulomb's law states that the electrostatic force between two charges is directly proportional to the magnitude of the product of charges or magnitude of the product of charges, and inversely proportional to you can write down proportional to the square of the distance between them or separation. The square of the distance between them. The distance we are denoting by r. Okay. Mathematically, we can write down this law as F is directly proportional to magnitude Q1, Q2. F is inversely proportional to, or you write down Fc Coulomb's law, R square. By combining both the equations, we can write down F is equal to, when proportional sign remove, the constant will come K Q1 Q2 by R square. Okay. If two charges, like charges are there, the Coulomb force will be negative. Like charges repel each other. Like charges repel each other basically. So Coulomb's law, according to that, and unlike charges attract each other. How we can induce the charge in a body? By induction, by conduction, earthing and all. You have gone through those methods. Okay, induction मतलब एक body charge नहीं है. You can close एक another body charge लेकर आओगे तो there is a charge separation between them. So induction वहाँ phenomena है. Unlike charges, attraction होता है उनमें. ठीक है. This is a K. K is known as constant, and its value is 1 by 4 pi epsilon naught, which could be also written as 9 into 10 raised to the power 9. You can also figure it out, limit and unit, by simply multiplying this R on other side and Q1 Q2 like that. So it will be Newton. Every force has a unit Newton. Newton meter square per Coulomb square. Here the epsilon naught is the permittivity of free space or vacuum. Vacuum, which value remains same for air also. Epsilon naught can be written as 8.865 into 10 inverse 12, just opposite to the unit of K because it is inverse. So Coulomb square per Newton meter square. Okay, Newton meter square. So this is the formula, and suppose there is F vector. We are in vector form. How we can write down? So that formula can be written as K Q1 Q2 by R square into R cap. This is a unit vector along the distance between them. Unit vector. As you know, unit vector R cap can be written as R vector divided by magnitude of vector. So this formula will become F vector will be K Q1 Q2 by R square R vector divided by magnitude of R. This is also magnitude, this is also magnitude. So it will become K Q1 Q2 divided by R cube and R vector. So this is a vector form of Coulomb's law. It is kind of similar to the gravitational law. Okay. Now we can discuss about the epsilon naught little bit, which is kind of confusing topic for some of the students. Let's discuss about what is happening epsilon naught. So whenever two objects or two charges are placed nearby to each other or at some distance, there is some medium around it, and because of that medium the force between them, the force vary between them. Okay, so suppose if I'm saying there is a air or vacuum, the force will be maximum because particles are dispersed, and in vacuum there is no particle, so force will be maximum for vacuum and air. Okay, vacuum or air, where the epsilon naught value will be minimum value of epsilon naught, minimum, because as you see the force formula, which is 1 by 4 pi epsilon naught Q1 Q2 by R square. So if this value is minimum, this value is maximum. So F max epsilon naught will be minimum. But what about other mediums? For example, this Q1 Q2 charges are placed in water. So there are so many water molecules in between. So force will increase or decrease. There are so many water molecules. So force will decrease. So according to this formula of Coulomb's law, there is Q1, Q2. In the water medium, Q1 will remain Q1, Q2 will remain Q2. R, we are considering the R will be same for both of the medium in vacuum as well as this water medium. So what is changing here? The medium is changing. because of the medium, the water molecules are coming in between and force is decreasing, and that is there comes the factor called epsilon naught. So the formula can be written in this case: force in medium is 1 by 4 pi epsilon naught of medium, permittivity of medium, not vacuum, q1 q2 by r square. How we can figure it out this EM? So we use the concept of relative permittivity. Relative permittivity. Relative permittivity is E written as EM upon epsilon naught. Permittivity of medium divided by permittivity of vacuum. So EM can be written as E into epsilon naught. Is kind of ratio. Relative permittivity, like you have a refractive index. So it could be, suppose for water it is 1.5. For water, EM is your 1.5. Then EM will become, put down the value of E into epsilon naught. Okay. Now apply the formula. Force on 1 by 4 pi epsilon medium EM q1 q2 by r square. So 1 by 4 pi EM can be written 1.5 times of epsilon naught q1 q2 by r square. Now you can clearly see this value is increased by 1.5 times. So force will increase or decrease? Definitely it will decrease in water. So force will be decreased comparison to this. It will change. So this is the easiest way to understand relative permittivity. The formula is very simple. That is, E can be, relative permittivity can be written as epsilon naught of medium, permittivity of medium divided by permittivity of free space. Medium to the, it is a ratio, permittivity of free space or vacuum. Free space matlab vacuum. So it is a ratio, and ratio will be 1, 2, 3. For other materials, it could be 5, 2, whatever. It will decrease the force between the charges. Because of the medium present between them, the force will decrease. Okay. So I hope you are able to understand this. We are going to also understand the superposition principle. So this is a very common principle. Suppose there are multiple charges in a vicinity. Okay, multiple charges. Q1, Q2, Q3, Q4. Suppose I need to figure it out, the force applied on Q2. Force applied on Q2. Q2. अब there are three charges nearby, Q1, Q4, Q3. So all three will apply force on it. If they are same, then they will repel. If they are opposite charges, then they will attract. So the resultant force will be the vector sum of all the forces acting on this Q2 charge. Okay, we can write down F net can be written as force on second charge, या first charge you can write down, so it will be easier for you. This is one. Okay, this is one. So force on first charge due to second charge plus force on again first charge due to third charge plus force on again first charge due to fourth charge. So it is a vector sum of all the forces. How we can figure it out? This forces in some examples we are going to discuss in next video. Until that, bye bye, take care. So there is some vector laws we are going to use, and like, share and subscribe the channel right now.